Okay, so let's start the first day target. So this is given for 2nd February, and let's start with the discussion. So, right. So before starting this discussion, if you have not attempted these questions, please try to attempt it first and then watch the video. I will also try to put the timestamps for the individual numericals here. One more thing, please try to post the answers in the comment section. Okay, so let's start with the first video. First question. So the first question is about this. A rocket is fired vertically up during the burning of the engine, which lasts for the 50 seconds. A constant acceleration of 2g is observed. And what is the speed of the rocket at the end of 50 seconds? And also we have to calculate the maximum height to which the rocket will rise before it begins to fall back. Now you need to understand one thing. As soon as we see rocket here, we tend to understand कि ये rocket motion से question है, right? It is the question of variable mass, but it is not. Because if you will understand, when there will be a question from the rockets, there must be mention of thrust, or there will be some mention of the exhaust velocity and all those things, right? So this is a plain question from the kinematics. So the very first approach towards the numerical is to understand कि किस topic का question है, what are the concepts involved here, and what is the formula we are going to use here. So as soon as you will understand that key, it is coming from the equation of motion. So you will be able to do that, right? Now, one more thing, what I have found in this question, most of the people start writing V is equals to U plus AT wala concept directly, right? This is not a CSE compatible method, right? So what we have to do, we have to start from the equation of motion and then we have to solve it. Yes, it will sound like कि ज़्यादा पेज लगेगा, ज़्यादा टाइम होगा, ज़्यादा लेंथी होगा, बट इट्स हाउ सब्जेक्टिव थिंग्स वर्क, राइट? सो वी नीड टू अंडरस्टैंड दैट थिंग ऑल्सो. So we know that key equation of motion is that key net external force on a body is equals to m into d square x upon dt square, that we know. Here we need to find out the velocity, so we can directly use that here, that key dv by dt is equals to f net external by m, that is the acceleration. Now this is the rocket. I'm not making the rocket. This is the particle which is moving upward. This is our rocket. So let's take upward as positive and downward as negative. So what we need to understand here, that this A, it is moving upward. Okay. So we can write here that dv by dt is A, and what is A given here? It is 2g. Now remember one thing, we are doing for 50 seconds only. If you will see that for this rocket, what will happen? For this rocket, what will happen? This is where it will start and it will go till height, let's say h1. And till now, the acceleration is 2g given, and this 2g is upward. Now, after that, what is the speed of the rocket at the end of 50 seconds? At this instant, let's understand the speed is v. This v we need to calculate it, right? We know that here it has started with the u is equals to 0. It just started. So we will use this thing. So dv by dt is equals to 2g. Now we have considered upward motion as positive. So you will simply write 2g. Now you can integrate it easily. So for v, it will be from 0 to v, and 2g is constant. You can take it outside. Dt, it will be 0 to t. So let's say t is equals to 50 second, which is the given time. At this height, t is given, that is 50 seconds. So we need to calculate this. So if you will integrate it, that's a very easy integration. It will be simply 2gt. Now if you will put the value, it will be 2. Now what is the value of g? You have to take 9.8 meter per second square. Now remember one thing, whenever we have to use the constant, we should always prefer the value which is given in this question. If this question, it was given 10, we have to use 10. We don't have to use our brain when the value of constant is already given in the question. Now if you put the 2gt, that is 9.8 into time is 50, the answer will be in meter per second, and if you calculate it, it will be coming out to be 980 meter per second. So much high speed this uh, rocket will get. Now, next, what they are asking, calculate the maximum height to which the rocket will rise before it begins to fall. Now, at this time, what we have done that during the burning of the engine, at this point, engine stops. But we know that it has velocity, it has momentum, so it will rise further up. So it will, let's say it will rise till here, and let's call this height as h2, right? Now understand this height h2, will there be any acceleration? So yes. So the rocket is moving upward, but the acceleration will be downward, and it is nothing but acceleration due to gravity. So acceleration will be g downward, right? Now the next part of this question, this is the first part that we have done. In the next part, we have to calculate the maximum height. So what will be the maximum height? So maximum height, again, when it will get here, its velocity, let's say v dash, will again become 0. So at the maximum height, its velocity again will become 0. So h max will be nothing. It will be h1 plus h2, right? So we have to calculate both. So let's calculate them. It's very easy to calculate. Now h1, for h1, we can use the above thing, and we can simply write that the acceleration can also be written as v into dv by dx. This we can rearrange now. dv by dt, we can multiply this with dx by dx. So dv by dx, dx by dt will become v dv. So acceleration will become v dv by dx. Now if you will put it in the first case, h1, so it will be v dv, from where to where? From 0 to v we are having, and the acceleration in this case, it will be a bar into dx, from 0 to h1 we are going, right? So if you calculate here, you will get the value of h1, right? And here h1 will be equals to this. Let's calculate. So it will be v square by 2, and here it will be a into h1. What is the value of v square and this? So v square was 2gt. So it will be 4g square t square by 2, and the acceleration, this was 2g into h1. I am calculating more so that you can understand it. If you're able to understand like this, so let me know in the comment section. So I will trim some of the calculation. So this is what I am doing just to make you understand कि ऐसे solve होगा. This is 2, this is g, and so we can simply write that it is nothing but it is equals to 2 से 2 खत्म gt square. So for this h1 we can do that. For h2 what we can do? h2 we know that it is going from v. Same thing we can apply here also, right? Same thing we can apply. So integration v into dv is equals to a into dx. From it is going from h1 to h1 plus h2. This is for the first scenario we are talking about. This is for the second scenario. So for the second scenario we are talking about, it is going from h1 to h1 plus h2. So now you can understand that it is going from v to 0. So it will be minus v square by 2 integration. And this a is what? Gravity, minus g. Why? Because upward direction we have taken positive. Vector hai to niche minus g. And here we will, if you solve it, it will become h1 plus h2. Put the limit minus h1. So h1 cancel out. Minus minus cancel out. Now v square is, again we know that from here it will be 4g square t square by 2 g into h2. So from here we can understand that the h2 will be, g will be cancelled out, and 2 will be cancelled out here. So it will be nothing but it will be 2gt square, 2g t square. So what is my maximum? So h max will be h1 plus h2, put it. So 3gt square. Now you have the value. T is 50 second, g is 9.8. If you put them, it is coming out to be 7350 meter. Now you have to understand here, and you have to focus on two things. First is the value, right? I might make calculation mistake. You have to double check it, although it is correct value. I have checked it here. First thing, that your answer should be accurate, and second thing, the method you're using, right? V plus U, V is equals to U plus AT. Can we use it? Yes, you can use it when you are using any objective type examination, because it is coming from this only. For a constant acceleration, you write these formula, but we don't have to write the shortcut formula. We have to get it from the main equation or main law. So again, from the second law, again, we are not going into the writing part, है ना? Just the plain numerical. So this is how you will solve it. Okay. Coming down to the next one, prove that E and E1 are respectively the neutron energies in the laboratory system before and after collision. So from here only you will be able to understand that it is the question of collision, right? Now scattering is given. There is nothing mentioned of which type of collision it is, but it is given here the center of mass, right? So from here you can easily understand, like here we have written कि equation of motion से सवाल था. This question you can easily understand that here something of the L frame and C frame is there, and plus what type of collision is it? It is. So you can understand that here we are talking about neutron, right? We are talking about nucleus of mass number A. So these type of scattering we have already covered in our foundation batch, that these type of scattering are elastic scattering, elastic collision, right? Now using these two, we are going to solve it. Now whenever you have C frame and L frame, and so I have given you two things to understand. For the elastic collision, I have told you that the velocity before and after the collision remain same. So for example, understand here. So here you can understand that in this question, we have this small ball, and this is of mass m. This is my neutron. Now it is going to collide with some nucleus which has a mass ma, which has mass ma. Now you need to understand one thing. Although we have covered these things in detail in classes, so I'm not going to spend time on these things. I'm just studying the facts. So that this is, let's say it is coming with u velocity and it is primarily at rest. This is the initial condition. After condition, it will stay still be at rest, but after this will have the velocity v. I'm writing in the vector format only, you can understand. It is not important to understand कि किस direction में जाएगा. Again, it depends upon the scattering. If you want to understand, it will again scatter with like this, like it will scatter like this, right? And this will be the angle of scattering. Okay, so this is the complete scenario. Now understand, in elastic collision, if you see from the center of mass frame, I have told you one thing, that the magnitude of velocity or the speed before and after collision remain same. So I can simply say this thing, that v1c, velocity of the first particle visible to center of mass before collision and after collision will be same. And what is the center of mass? If I have to understand v center of mass, it will be what? It is at rest. So m into u upon total mass, that is m plus ma. So if you can eliminate m, so it will be u upon 1 plus a. Now if you put it here, what will the magnitude? You can understand that it will be nothing but u1 minus, let's write u only, u upon 1 plus a. So it will be simply u upon 1 plus a. चलो 1 कर ही लेते हैं. You should understand that we are talking about this particle only. So this is possible only the elastic collision in center of mass frame. If you are watching from the center of mass frame, we can write this thing. Now for the lab and this, I have given you one very important diagram, and that I want everyone to understand, that we know that what is V1C. V1C is simply V1 minus V center of mass. This we know. Now we can simply make the diagram like this. Vector addition hai. It will be V center of mass. And if you add V1C, what you will get? You will get V1. It is coming from the vector diagram only. And this angle, if we are watching from the center of mass, let's call it theta dash, where theta dash is known as scattering angle in center of mass. So before solving this question, इतना basic तो पता होना चाहिए. Otherwise, you will understand कि numerical ability में दिक्कत है. No, it's not your numerical ability. It's about the basic concept. Okay. Now let's understand the question. So what they are asking prove that E and E1 are the respective the neutron energy in the laboratory frame, right? It is the neutron energy in the laboratory frame before and after collision. So write it down. So what is E1? E1 by E we have to find. What is E1? Simply half mass was m, speed was v1 square, half m u1 square. This is now in the laboratory system. We are writing in the laboratory system. So what is in the laboratory system? So before collision, it is, let's say, u1 and it is v1. This is what we are writing. So u1 and v1. So half m and m will cancel out. It will be v1 square upon u1 square. This is what we have to understand. This is what we need to find out, v1 by u1. So we can find it from here only. So from here, we can simply write that v1 ka whole square, and we are keeping the mod vector addition, is equals to v1c plus v center of mass ka whole square. So what you can write here? It will be v1 square. It will be v1c ka whole square plus v center of mass ka whole square plus it will be 2v1c dot v center of mass. Simple vector. Now what is the angle between this v center of mass and v1c? It is theta dash. So we can again write that it is nothing but it is 2v1c into v center of mass into cos theta dash. This is what we can write here. Now v1 square, what is v1c square? You can here v1c square is equals to u1c square, and u1c square is equals to this. So you can simply write that key, it will be u1 square a square upon 1 plus a ka whole square. What is v center of mass square? Here we have find already. So u square upon 1 plus a ka whole square plus 2. What is v1c? Just we have written ua upon 1 plus a, and it is simply u into 1 plus a cos theta dash. Now from here, take the u this side. So v1 square u1 sorry u1 v1 upon u1 square will be what? Here you are having a square, and नीचे देखो in the denominator it is 1 plus a square. So a square, for this it will be 1 only. For this it will be 2a cos theta dash. Now try to match with the answer. 1 plus a square plus 2a, and this is what they have written as mc. So done. No, I'm not expecting and not we are not going into these things. But what we do in basically launch and advanced batch and what you required for the answer writing, that we need to interpret this thing. So here we have theta dash, right? So now we know that if theta dash will be 0, so this will be the maximum value. And when theta dash will be equals to pi, this will have the minimum value. We know that, right? If theta dash is 0, it will be 1 plus a ka whole square, 1 equals to 1. This you can write. And what is theta equal to 0 called? We know that it is known as forward scattering. This what we known as back scattering. So these things you can write in the interpretation. Again, I'm not going to go into these things. We do these things in the launch classes, but just थोड़ा सा दिमाग खोलो and try to think upon these things. If this is the result, everyone is going to write that. What we can value add to the examiner without spending much of the time, right? So theta 0, it will have the maximum value. Theta pi equals to minimum value. Back scattering and forward scattering we all also know. We also know that if A is equals to 1, that means if the nucleus is hydrogen, right? So here we can have the maximum velocity transfer. We know that in elastic collision, if the particles are identical or the same masses, if it is coming from V, it is at rest. After the collision, it will become rest and it will be at V. The maximum energy uh, transfer or maximum velocity transfer here. And that's why we use this thing in nuclear moderator. This is just for an example I am giving you how we can make our question exam worthy or better than the others, right? Again, in this numerical masterclass, I am not focusing upon these interpretation. I am focusing more upon the mathematics and how to approach that thing. Okay, okay, going ahead. Next question is a rocket of mass 10,000 kg, 1000 kg, sorry, is ready for vertical takeoff. The exhaust velocity of the fuel is 4.5 kilometer. The minimum rate of fuel ejection. Now, once we verify this minimum rate of fuel ejection is there, we can understand that this question is coming from the rocket motion. So this question is coming from the rocket motion system of variable masses. System of variable masses. So now we are going to apply the rocket concept, right? Now again, if I ask you, I hope you know that the minimum rate of fuel injection we have to find out. For example, for first, we have to find out dm by dt. I hope you know. Although for the mechanics, I have already uploaded the classroom notes. You can understand key dm by dt. Okay. So basically, this is the mass which is exhausted out. So this is the rocket, and we know that there will be some exhaust velocity, right? And let's say oppose this direction is positive, this direction is negative. On this complete rocket, there will be only one force which is acting, which is gravity as of now, right? The external force which is acting is gravity, and this is our system. The rocket plus the exhaust is our system. Now, the effect of changing mass in the rocket in the given condition, we can neglect that. So we are neglecting that and we are moving ahead with this. Now we know that, now we know that this dm by dt, the rate of fuel ejection, fuel निकल कहां से रहा है रॉकेट से, so it is equals to the rate of dm by dt. This is the formula you should knowing. Apart from that, what else formula we have? We have this formula: f external is equals to m, the rocket of mass of rocket, dv by dt, the velocity at which rocket is moving, right, plus u dm by dt. We can use this also, or you can use the similar m dv by dt, and you can change this u minus u capital dm by dt. So whatever you feel comfortable, you can use it here. Now the first question is asking that the minimum rate of fuel injection so that the rocket is just balanced. For the just balance, that means it has not gained any speed, forward speed yet. It is just going to uplift. So what we will do, this dv by dt will become 0. Now this dv by dt will become 0. We can write, understand that this u is also downward. Exhaust speed is downward and v is upward. We know that नीचे जाता है फ्यूल उसका जो एग्जॉस्ट मास है एंड ऊपर रॉकेट जाता है. सो वी कैन यूज द साइन कन्वेंशन, ऊपर वाला पॉजिटिव नीचे वाला नेगेटिव. सो ऑब्वियसली हेयर द इट विल बी माइनस mg, नेट एक्सटर्नल इज माइनस mg, and here u and this we can put the value, so it will be minus u, right? And dm by dt is what? Minus dm by dt. Or you can use simply this one, this formula. So u is what? Minus u dm by dt. This formula we are using. So what we need to find out? We need to find out dm by dt. So it will simply become mg upon u. Now put the value. M is given 1000 kilogram. 1000. What is g? We will take 9.8. And what is u given? It is given as 4.5. Remember, kilometer per second. So we'll try to make it in the meter per second so that we get the values in SI unit. It will be kg per second. So once you will solve it, it is coming out to be 2.178 kg per second, right? Again, you try to match the answer and write in the comment box that if you have made it correct or not. This is the first part. Now second part, again we will use the same thing. So we can use here here we have some velocity. In the second part, it is saying the velocity acquired in 8 seconds if the fuel ejection rate is 2.5. So now the fuel ejection rate they have changed 2.5, and we need to find the speed at 8 seconds. Now this v will be something. Okay, so again put the values. Again this formula we are using. If you use this formula, everything will remain same. Minus mg will mg. Here again it will be ऊपर जा रहा है तो m dy dt positive, right? And here it will be u and will be dm by dt. Okay, so let's make things like this, like dv by dt will be equals to u by m dm by dt plus, sorry, minus g. Now you can use integration, है ना, dy dt from 0 to v. So let me do this thing for you also. So 0 to v, and this is again constant. So t, 0 to t, this t is given 8 seconds. So if you will do that, the value of v will be u by m into dm by dt minus g into t. So u by m is given, u is given 4.5 into 10 to the power 3. We are putting everything in SI units, so that the answer completely in SI unit. What is mass? 1000 kg. So 1000 kg. What is the dm by dt? It is given. It is given 2.5 kg. So put the value 2.5 kg. ये value मत put कर देना. It is given 2.5 kg, so we have to put that 2.5 kg, and now minus 9.8 value of g, and now we have to multiply it with the time into 8 seconds. Now put this thing in calculator, and the answer that you will get is 11.6 meter per second, right? Try to use scientific calculator. Try किया, use ही करना है scientific calculator, and you should be in a comfortable position that you are sure कि when you're writing these things in the calculator, you're getting the right result. So please play with some calculator and you will get the result. Okay, we can also interpret these things, but again, we don't have much time for those things in numerical masterclass. Okay. Okay, let's come to the question number 4. In question number 4, it is saying that a projectile of mass m explodes while in flight into 3 fragments. One fragment is m1, travels in the original direction of projectile. Another particle of mass m2 is traveling in opposite direction, and the third fragment m3 comes to rest. The energy released in the explosion is 5 times the kinetic energy of the projectile of the explosion. What are the velocities? So from here only you can understand that it is coming from the conservation of momentum and energy. So conservation laws we are using here, right? So first we need to understand this thing. Okay, let's draw the scenario. So let's say this is the bomb, and let's say at any point of time at this, it is going to break, and it is going to break into 3 components just before the collision, right? So I can understand that key all of them will be at same height. This is very important to understand, because you are writing a subjective paper. Try to understand it is not the numerical only for the sake of numerical, just you have to get the answer and you have to take one option. It is for your subjective paper, right? So you have to think like that only. So although I have drawn like this, थोड़ा सा इसको ऊपर draw करना चाहिए. So let's take these all are at same level. Okay, so this is the particle 1, it is going in this direction. Particle 2, it is going in this direction, and it is going to rest. So this is my m1, this is my m2, and this is my m3. So the m3 is coming to rest, right? Now what is saying this? What is the question is telling you that key m1 is traveling into the original direction of projectile, and m2 is traveling opposite direction of the projectile. Direction are changing. Sorry, direction they have given. So let's consider the velocity of this particle as v. Now, if a vector is in the direction of the same vector, so it will change only in magnitude. So let's take that this v1 is lambda v. It is in the direction of that. So lambda 1 v. And this m2 v2 is lambda 2 v. v2 as lambda 2 v. Now we know this thing. Now you can also minus lambda 2. कर लोगे तो ज़्यादा आसान होगा. Trust me, in this question, this framing of the mind is the most important aspect. It will reduce your calculation, right? And if you have less calculation to do, the accuracy, the chances of the accuracy becomes higher. You need to understand one thing. UPSC doesn't praise in unnecessary calculation. So calculation should be there. It should be doing from the scratch, but it should not be making it mathematically so lengthy that it is very time consuming to check. Okay. So now let's do this conservation law. First, momentum conservation. So what was the initial momentum? So it was having mass m. So mass m into v. What is the final momentum? इसका तो जीरो लिखेंगे m3 का. m1 and m2 का है. So what is m1? m into m1 into v1 plus m2 into v2. If you want to write, you can also write m3 into v3, right? This is going to be 0 because it's coming to rest. And now this we can write as m1 is m by 2, it is given, and it is lambda 1 into v, plus it is m by 6 lambda 2 into v. Now you can see from here mv will cancel out, and you will have some relation as 1, take the common, so it will have 6 equals to 3 lambda 1. So here it will be minus now. It is minus lambda 2. So it will be minus lambda 2. So this is my first equation. Now what is the second equation I can make from here? They are saying the energy released in the explosion is 5 times the kinetic energy of the projectile. ठीक है? The energy released in the explosion is 5 times the kinetic energy. That means I can say that the energy released is 5 times the initial kinetic energy, half mv square. So from here also we can find out the value of v. V will be nothing, it will be 2e by 5m, and this we are going to use later. So we can find out v. Apart from that also I can write, let's do the energy conservation, right? If you, this is the momentum conservation we have did, let's do the energy conservation. So what are the energy it will have? So for it will have ug, gravitational energy, potential energy. Next, what will be the kinetic energy? Half mv square will be the kinetic energy. What else energy it can have? It will have internal energy E. यही तो explode होके निकल रहा है, right? So it will have external energy E, which is given here, which is 5 times the kinetic energy. We know that from here. Will be equals to, what is the energy next? Half m1 v1 square plus half m2 v2 square plus half m3 v3 square. Obviously, it is at rest, so it will be 0. Now we can put it here. This E is what? It is 5 by 2 mv square. So 5 plus 1 6 mv square by, so it will become 3 mv square. Here we will have m by 2 and all those things. So we can simply write that. So it will be 1 by 2 m by 2 lambda 1 square v square plus 1 by 2 m by 6 lambda 2 square v square. Now mv square cancel out, mv square cancel out, mv square cancel out. So from here you can have, take the, so here you have 4, here you have 12. So let's take 12 here, it will become 36 here. It will simply become 3 lambda 1 square plus lambda 2 square. Now we can put the lambda 2 square. What will be lambda 2 here? From here lambda 2 क्या लिख सकते हैं, इधर जाएगा तो 3 lambda 1 minus 6. So put it. So 3 lambda 1 square plus 3 lambda 1 minus 6 the whole square. So you will get here 3 lambda 1 square plus 9 lambda 1 square plus 36 minus 36 lambda 1. So 36 will cancel out. So you will have 0 equals to 9 3 is 12. So 12 lambda 1 common, lambda 1 minus 3. You know that lambda 1 cannot be 0. So from here you have only one option, the lambda 1 is 3, and that means that your v1 is equals to v2 is equals to 3v. Now I'm writing in the magnitude only. You know that ki v1 and v2 are opposite in sign. And what is 3v here? 3 into root under 2e by 5m. 2e by 5m. So this you can write. I hope this was very easy. But once you will not use this method, then it will become a little bit tough to solve. Okay. I hope you guys are solving these questions and try to post the answers. Try to post whether you're liking the solution or not. Although liking is a negative connotation, whether you're able to understand the solution or not. If you want me to discuss in detail something, you can ask, right? So I will try to discuss in the next video. Okay, let's come to the last question of the day. A body of mass m splits into two masses m1 and m2 by an explosion. After the split, the body moves with total kinetic energy t in opposite direction so that their relative speed is this. Again, this is coming from the conservation of momentum. So the topic is conservation laws. Now this was our mass m, and this mass is now exploded into m1 and m2. Now we know that if it is at rest, the explosion will take place in such a way that it will move in this direction, it will move in this direction. So let's say it is p1, it is p2. From the conservation of momentum, we can write that the initial momentum was 0 and the final momentum was p1 plus p2. From here, I can say that both will be p1 will be equals to p2, and let's take it p, because initially the momentum was 0. So p1 equals to minus p2. That means their magnitude are same. Now from the question they are saying total kinetic energy is t, and they're moving in opposite direction. They have already mentioned. And let's take it is moving with velocity v1. It is moving with velocity v2, right? Relative speed nikalna hai, right? So we can say that what is v relative? If they are moving in opposite direction, it will be v1 plus v2. This we also know that. That's the easy concept. Okay, so let's try to connect with the total energy T. So now the total energy of this system is T. What we can write? Simple. Half m1 v1 square plus half m2 v2 square is equals to T. You can convert this m1 v1 into p1. So p1 square by 2m1 plus p2 square by 2m2 equals to T. Now we know that p1 square and p2 square will be same because p1 and p2 magnitude are same. So we can take p square by 2 as common. We will have 1 by m1 plus 1 by m2 equals to T. So from here we can write that p square by 2, it will be m2 plus m1 upon m1 m2 equals to T. What is m1 plus m2? It is m. So what will be p here? So p here will be 2t m1 m2, 2t m1 m2 divided by m, because this m1 plus m2 is m. Now what we need to find out? We need to find out v relative. V relative is v1 plus v2 moving in opposite direction. I hope this is very, I, I think it do not need any discussion. So v1 plus v2 because they are moving in the opposite direction. What is v1? It is p1 by m. What is v2? It is p2 by m, right? And we are writing only the, as long we have written v1 plus v2 here, that means we have eliminated the vector scope. We are doing with the scalar. So what we can write? So p, I can take common. Again it will be 1 by m1 plus 1 by m2. So we can put it here. So it will be 2t m1 m2 upon m. m1 plus m2 will become m upon m1 plus m2. So again multiply. So नीचे आ जाएगा ये. It will be 2t by m upon m1 plus m2. Right? Now, when you got these relation now, always try to interpret. Okay? One example I can give you here, that when will be v relative will become maximum. ये maximum कब होगा? Obviously, you need to minimize this thing, right? So when m1 m2 will be same and all those things. So you can play on these things. You can play on this only when m1 greater than m2, what will happen? When m2 greater than m1, what will happen? So these things you can play. But again, for these series, we will try to limit ourselves into the correct solution, that we are able to understand the approach and we are able to write down the final answer. Okay? That's all for this video. We'll meet tomorrow at the same time. and we'll solve day 2. Thank you everyone. Bye.